Yes, I am Professor K. Nagnath. I have completed my M.Tech in Electrical Engineering from Pune University, Maharashtra. Okay. Today, I will give you the demo lecture on electromagnetism. So, this electromagnetism term related to the electricity and magnet. So, all of you know that some materials having a property to attract the iron filings towards itself. That materials are known as a magnet. Naturally available magnetic materials are neodymium iron boron. It is a naturally occurring magnet. But by using the electrical energy, we can produce the magnet. That magnet is called as an electromagnet. This electromagnet, it will be produced by using the electrical current. So how it will be produced? That phenomena is nothing but the electromagnetism. Okay. So first of all, we will going to study what is the actual application of this electromagnetism, because once we know the application for this electromagnetism, then and then only we will going to interestedly going to learn what is meant by the electromagnetism. So one thing I want to tell you that in our day-to-day life we are using electrical motors in our single phase fan, in our water lifting motors. Okay. And also we are using a lot of applications with rotary and reciprocating motion as well as sliding motion, and it is occurred because of only the electrical motors. Okay. So these electrical motors specifically works on this electromagnetism phenomena. Okay. So first of all, we will going to study the what is meant by the actual electromagnetism. Or first of all, we will going to study the principle of electromagnetism. Okay. So electromagnetism having a wide application in electrical motor application. Okay. So our duty is to study what is meant by the actual electromagnetism. Okay. So electromagnetism, it is word itself going to indicate that the magnet which is produced because of the electrical energy. All of you know that electrical current going to flow through the metallic conductor because of metallic conductor having least resistance. Okay. So whenever the current will going to flow through the electrical conductor, at that time what will happen? There is a movement of charged particle from higher potential to lower potential. Means what? Electrons will going to move from higher potential point to lower potential point, and it will establishes a electrical current. This electrical current, whenever it is flow through the conductor, it will act as a nano electromagnet, and it will going to produce a magnetic field around the conductor itself. So the production of a magnet around a current carrying conductor, this phenomenon is first of all invented, or we can say that discovered by the great scientist H.C. Oersted. According to the H.C. Oersted, sir, the electromagnetism can be found by using right hand thumb rule. Okay, right hand thumb rule. So this right hand thumb rule gives you idea about the direction of current carrying direction of flow of electrical current through the conductor and the magnetic field set up around the current carrying conductor. Means indirectly we can say that from this right hand thumb rule we can guess about the direction of magnetic field. All of you know that natural magnets having N and S pole. So magnetic field in a natural magnets, it is from N pole to S pole. Okay, means what? Magnetic flux lines of forces going to flow from N pole to S pole. Similarly, with the help of this right hand thumb rule, we can guess about the magnetic field direction and the current flowing through the conductor direction. So let us have a look on this PowerPoint presentation. Circular magnetic field developed around the current carrying conductors. That current carrying conductors will going to produces a magnetic field, and that magnetic field produced because of this current carrying conductor, it is set up around itself. Okay, around itself. Okay, so according to this right hand thumb rule, if we suspend a current carrying conductor in our right hand, but imagine that if we hold the current carrying conductor in our right hand, it is chances to get the electrical shock. To avoid that one, do not practice at your home. Okay, this right hand thumb rule, do not uh, do at your home, because it will causes the electrical shock to you. Okay, so this right hand thumb rule, according to this right hand thumb rule, we have to imagine a current carrying conductor. Let us say this pen going to carry the electrical current. Okay, so this is a current carrying conductor. Okay, so we have to hold this current carrying conductor in such way that our right hand fingers, we have to curl around it, around this current carrying conductor, and we have to outstretch the thumb, outstretch the thumb, as like this video. Okay, have a look on this video, you will get the how to do the or how to develop the practical model for this right hand thumb rule. Okay, you have to imagine a current carrying conductor in your right hand in such way that our curved finger of a right hand around the imaginary current carrying conductor, and we have to outstretch the thumb. Okay, so according to this right hand thumb rule, the curled finger will going to show you the direction of magnetic field, and this outstretched thumb show you the direction of current flowing through the conductor. Means what? From for this current carrying conductor, current will going to flow in upward direction, and magnetic field will going to set up in this direction. Magnetic field will going to set up in this direction. Okay, so have a look on this image, you will get the idea about the right hand thumb rule. Okay, so according to this right hand thumb rule, this is over here, this is a current carrying conductor, and this is our right hand. Okay, we have to hold a current carrying conductor in our right hand in such way that we have to curl our right hand fingers around this current carrying conductor, and we have to outstretch the thumb. Okay, we have to outstretch the thumb. So from this diagram, it is clear that the current, it is flowing in upward direction, and magnetic field, it is exactly in along with the direction of this curled finger. So this red colored pointed arrow going to show you the direction of magnetic field produced around the conductor. So this is about the electromagnetism. Okay, so from this diagram, it is clear that the magnetic field direction and current direction, it is exactly perpendicular to each other. Exactly perpendicular to each other. Okay, we can understand this right hand thumb rule in our mother tongue as a Hindi. ओके। मुझे ये आपको बताना है कि ये जो इलेक्ट्रोमैग्नेटिज्म है, ये इलेक्ट्रोमैग्नेटिज्म बेसिकली आता कैसे है। आपको मालूम है कि नेचुरली अकरिंग मैग्नेट्स होते हैं, वो मैग्नेट आयरन फिलिंग्स को और आयरन के स्मॉल स्मॉल पीसेस को अट्रैक्ट करते हैं। सिमिलरली ये इलेक्ट्रोमैग्नेट्स क्या करते हैं, आयरन फिलिंग्स को अट्रैक्ट करते हैं। ओके, सो in order to realize this electromagnetism we have to do one experiment, that is on right hand thumb rule. ओके, आपको क्या करना है, एक एक्सपेरिमेंट करना है, लेकिन ये एक्सपेरिमेंट आप घर पे प्रैक्टिस ना करें क्योंकि आपको इलेक्ट्रिकल शॉक लगने का चांस है। तो अवॉइड दैट वन, वो न होना, इसलिए हमें क्या करना है, इमेजिन करना है कि एक करंट कैरिंग कंडक्टर हमें राइट हैंड में हम ऐसा होल्ड किए हैं, पकड़े हैं। तो इस तरह से हम राइट हैंड को मोल्ड करना है कि हमारे कर्व फिंगर क्या करेंगे, एग्जैक्टली रैप करेंगे करंट कैरिंग कंडक्टर को, और हमें क्या करना है, थंब आउटस्ट्रेच करना है। ओके, ये हो गया राइट हैंड थंब के बारे में। और यह जो कर्ल फिंगर है वो हमारे मैग्नेटिक फील्ड की डायरेक्शन बताएंगे हमें, और ये जो आउटस्ट्रेच्ड थंब है वो हमें करंट की डायरेक्शन बताएगा। ओके, दिस इज अबाउट द राइट हैंड थंब रूल। ओके, नेक्स्ट वी विल गोइंग टू स्टडी द एग्जांपल ऑफ इलेक्ट्रोमैग्नेट। ओके, इलेक्ट्रोमैग्नेट के एग्जांपल हमें देखना है। तो आपको मालूम है हम इलेक्ट्रिकल करंट दोनों तरह से बना सकते हैं, एक डीसी करंट है और दूसरा है एसी करंट है। तो हम डीसी करंट के यूज से हम परमानेंट मैग्नेट जैसे, नेचुरल मैग्नेट जैसे हम कांस्टेंट मैग्नेटिक फील्ड कैपेसिटी का मैग्नेट बना सकते हैं। ओके, सो हैव अ लुक ऑन दिस स्लाइड, यू विल गेट द आइडिया। We have to take one a current carrying conductor and we have to make its coil। मुझे मीन्स व्हाट, हमें क्या करना है, एक करंट कैरिंग कंडक्टर लेना है और उसको कॉइल में बदल देना है, और उसको क्या करना है, डीसी सप्लाई देना है। मतलब हमें क्या करना है, हमें ड्राइव सेल यूज करके उसको इलेक्ट्रिकल करंट उसमें से फ्लो करना है। तो क्या करेगा, जब इस कंडक्टर में करंट फ्लो हो जाएगा तो क्या करेगा वो, उसके अकॉर्डिंग टू एसी ओवरस्टेड लॉ मैग्नेटिक फील्ड क्या हो जाएगा, उसके आजू बाजू में सेटअप हो जाएगा। ओके, तो ये मैग्नेटिक फील्ड जो है वो मैग्नेटिक फील्ड कांस्टेंट बनेगा। ओके, ये है डीसी मैग्नेट, और बाय अप्लाइंग द डीसी वोल्टेज वी कैन प्रोड्यूस द इलेक्ट्रोमैग्नेट। ओके, वी कैन प्रोड्यूस द electromagnet। Okay, the magnet produced by this DC voltage, it is a constant magnitude magnet। Okay, means what, in this case constant magnetic field strength will be produced। यानी कि क्या है, डीसी सप्लाई जब हम यूज करेंगे तो उस टाइम पे जो मैग्नेटिक फील्ड डेवलप हो जाएगा अक्रॉस द कंडक्टर, ये कांस्टेंट मैग्नीट्यूड का डेवलप हो जाएगा और इसका मैग्नीट्यूड वैरी नहीं हो जाएगा। ओके, सो फ्रॉम दिस सर्किट डायग्राम ये अच्छी तरह से हमें क्लियर होता है कि डीसी वोल्टेज सोर्स जब हम उसको अप्लाई करते हैं करंट को, उसी टाइम उसके आजू बाजू में मैग्नेटिक फील्ड प्रोड्यूस होता है। ओके, ये जो मैग्नेटिक फील्ड है वो क्या है कि नियर टू कंडक्टर कैसे होता है, स्ट्रांग होता है। जैसे जैसे हम कंडक्टर से हम बाहर की ओर जाएंगे, मतलब हम उससे दूर जाएंगे, उसी टाइम पे उसमें जो मैग्नेटिक फील्ड प्रोड्यूस हो जाए हुआ होगा वो हमें उसका स्ट्रेंथ कम मिलेगा। ओके, मतलब जैसे जैसे हम मैग्नेटिक फील्ड को चेक करेंगे कि हाउ टू इट विल बी एक्सपीरियंस्ड। ओके, iron is a better conductor of magnetic flux than air. The air core of an electromagnet can be replaced by a piece of soft iron. okay, of piece of soft iron. Okay, so some materials are there. By using that material, we can produce the electromagnet. That materials must have the uh, magnetic flux carrying capacity. Means what? मान लो कि हमें इलेक्ट्रोमैग्नेटिक किस तरह के मटेरियल में हम यूज कर सकते हैं, तो हम इसको